Welcome again to my channel. Let's look at problem B of Codeforces Round 855. Count the number of pairs. So we are given a string S which contains both uppercase and lowercase letters, and for each pair of lowercase and matching uppercase we can get one burl. I don't know what that is, but we need to maximize the number of burls. So basically we need to find pairs like small a and capital A, small b and capital B, and so on. First we need to find these pairs, then to get a higher score we can perform an operation. The operation we can perform is that we can convert a lowercase letter to an uppercase letter or an uppercase letter to a lowercase letter. But we can perform this operation only k number of times, and then we need to maximize the number of burls we get. So let's look at the explanation. Here I have taken the example which is given in the question. What we can do to find pairs is that we can first of all count the number of occurrences of the small letters and the capital letters. So over here small a is 1, 2, 3 and 4 times. So small a is 4 and capital A is 1 and 2 times. So capital A is 2. Let's write it down like this: A, capital A, capital A. For B, it would be 1 capital B and 1 small b. So B, B. For C, it would be 1 capital C, 1 small c. So that is C and C. And for E, it's just 1 capital E. And that's it. So how many pairs can we see here? We can see one pair here, another pair here, another pair here, and another pair here. So pairs are 4, but then we can perform more operations. So how exactly would we perform the operation, or rather where would we perform the operation? We can convert uppercase to lowercase and lowercase to uppercase. So if you notice here, there are two A's, and if we convert one of them to capital A, then this forms a pair. We can't do anything to this E because even if we convert it, there's nothing to match. So what will be the logic? The logic is first count pairs, then second would be to count scope. What is scope? The number of times you can perform the operation. And how would we count that? We basically count how many remaining elements are there. Like here it is 2, here it is 1, and so on. And we can divide that number, let's say count, by 2. And what this will give us would be the number of pairs possible. So something like a 3 would give us 1 pair, a 2 would give us 1 pair, and a 4 would give us 2 pairs, and so on. So we can just add the number of pairs possible to our original pairs. But there's a constraint. What? The number of times we can perform the operation is k. So what will we add? We will add the min of k comma scope. So that will take care of the limit on the number of operations. That's it. Nothing else is there in this question. So let's look at the code. This solution has been accepted. Let's just look at it. I've taken n, which is the length of the string, k the number of operations, and made a lowercase and uppercase array. And for each character, if it is uppercase or lowercase, accordingly I've stored the frequency. So the first element of lower stores the count of small a's, and the first element of upper stores the count of capital A's. And now we take a matching variable and run through the loops, lower and upper. Both are of size 26 because 26 letters of the alphabet. And we'll add the number of pairs that are already present, which is the min of lower comma upper of I. And we'll add the difference of the two, which is the extra number of characters, to the scope. And again after that, and again once that is done, we can add the min of scope comma k to matching, and that will be the answer. That's it. Thanks for watching, guys.